Hello, my name is Andrea Lubick. This is week number 4 of our interactive experiments. Today we're going to be making elephant toothpaste using peroxide, some soap, and we're going to be using some yeast as the catalyst. Okay, so these are what we are going to be using. So we have some dish soap, it's just classic Dawn. We're going to be using 3% hydrogen peroxide because I was not able to find 6%, so it should still do the trick. And we've got some Fleischmann's instant yeast, so it'll be pretty fast acting as far as that goes. I'm actually going to mix it up right now so that we see. We're creating catalase here using the yeast, and that's going to help us to break down our hydrogen peroxide into water and oxygen a bit quicker than it would naturally over time. Usually the expiration date is a few years out, so I'm trying to speed that up, by a few years. So we're just going to continue to mix this a little bit. Sorry, birds are in the way. They're trying to help us today. So I'm going to continue mixing that beyond this. But we do already have our hydrogen peroxide mixed up. I used about 200 milliliters here. I already squirted in some soap, and I used some classic blue and some red food coloring. I used a little bit more blue, but we're looking for some swirls or maybe just getting that purple color. So I drew a little diagram here of what should happen when we add all of these ingredients together. So we used our water, we mixed it with the yeast, so that creates our catalase or catalyst here that's going to speed up our reaction. We've added our dish soap, our hydrogen peroxide, and food coloring to get that color explosion. So our result here should be heat and oxygen, and then a lot of foam, which would be in the form of H2O and oxygen. I also wrote out how our formula should look. So we start with 2 H2O2 in an aqueous solution, which is going to be our hydrogen peroxide, which will decompose to 2 H2O in liquid form and some oxygen gas. So that's going to be in gas form, of course. We've also got our catalyst, which is the yeast, which we're adding in to speed up this process, like I've explained already. So for more foam, use a higher concentration of peroxide for a more thermogenic reaction. Now, this is going to be a lot higher percentage to get this result. It's still going to create heat, which is what we're looking for. And the dish soap actually acts as a surface tension addition, which adds the stickiness, so it creates that foaminess. Fun fact, catalase is also found in potatoes, and we even create it in our own body, and that's why when we get hydrogen peroxide on a cut or scrape, it bubbles up, so it naturally kills those germs. So that's just a little fun fact I wanted to add in there about our reaction today.
2.
Alright, so we came outside, taking our operations out here over the grate so we're not getting bubbles all in the grass or all over the apartment. So I'm going to mix it and back away rapidly because, as you can see before, take 1 was a little bit too wet. So take 2, we put more soap in this time, so hopefully that gives us more surface area here. And I'm going to rapidly back away so I don't get it all over my shoes. Nope. Alright, so take number 3. I already know that I have a little bit too much water here, so the solution might be a little diluted. However, we are going to try it. Take number 3. Hopefully here comes the charm. It's rising at least. So the reaction has been sped up at least. It is creating exactly what the products we're looking for. We're looking for heat, oxygen, and water. We're getting that, just not in the quantity that we want, or as rapidly as we want. Okay, so after 3 trials, the first one was the most successful. However, we did not get footage on that one due to some technical difficulties. The other 2 were successes, however they did not rise quite as much as we would have liked to. Our ratios were incorrect The first one I added too much soap. The second one we added a little bit too much water.